Hello, everyone, and welcome to Science Explosion. My name is Zach, and I am coming at you from Hudson Public Library in Hudson, Iowa. Today, we are going to be talking about flying, floating, and everything in between. So let's get started. Alrighty, so supplies for today are pretty simple. The only things you'll need to follow along are paper. I just have a stack of plain white paper here, but you can use any type of paper that you want. You'll need some scissors to cut with, and then optional, but I think they'll help, you'll want some paper clips. If you don't have paper clips, then you can do staples, but the nice thing with paper clips is that you can take them back off and then reuse them in a different way. So if you want to change something on your things that you're building today, then you can. So I'd recommend paper clips if you have them. Alrighty, so let's start off just by jumping in and making a basic paper airplane. Now there are lots of ways to make a paper airplane, but I'm just going to do the simple way, and I'll show you the steps if you want to follow along. So fold your paper the long way, or hot dog style, like that. Line up the edges, smooth it out. So now it's folded in half like that. Then you unfold it, and then the next step is this top part here, the flat part, you're going to line it up so that that flat part is now touching where that crease is. So like that. And then you're going to fold that down. Try to get it so it's lined up as straight as you can. The more precise you are on this, the better. All right, so some of you might not know what the word precise means, and that is okay. So precise is a measurement in science and engineering of how exact something is, how close it is to that measurement. So you might have heard the term precision engineering, or seen that on commercials for things. So precision engineering is talking about something that is engineered very precisely. They tend to be higher quality things, and they tend to cost a little more, but they also last longer. Now these are paper airplanes, so I'm not expecting these to last a very long time, but the more precise they are, the better they'll fly. All right, so you folded it, so it looks like that. Then you're gonna do the same thing on this side as well. And look at that, I've already got it a little bit uneven. That's okay. So it should look like that. Then you're gonna do the same thing one more time. So get this flat part here to touch that crease in the middle, and then fold it over so that it looks like this. All right. And I know some of you who have made paper airplanes are already saying, Zach, you're doing it different than I do, and that is okay. There are lots of different ways that people have learned how to make paper airplanes. All right, and you might be able to guess the next step. It's do the same thing on the other side. Yep. All right. So now it'll look like that. I'm going to fold it in the middle crease again. So now it's folded in half. It should look like this, like almost a triangle, but with a little flat part there. All right, then this part you're going to fold down so that the flat part here touches this flat on the bottom here. All right, and then you can probably already guess the next step. Then you're going to do the same thing on the other side. Alrighty, and that is it. That is the most basic paper airplane you can get. So if you look at my design of a paper airplane right here, you'll notice that it's flat along here and then it's got a curve. Now, if you were to fold these in a little bit of a different way, you could get this curve going all the way along that way, and that'll make it fly differently. So if I were to toss this, which I will, it flies okay. It made it just a couple of feet with not a very good throw, honestly. It's only probably about 7 feet away. So I'm gonna go grab it again. All right, so what can you do different with this paper airplane to make it go just a little bit better? Well, you could have folded it a little more evenly than I did. But another thing you can do is add things to it. So this is part of engineering, understanding how things work and then asking yourself, I wonder what would happen if, and then doing those things. So one of the basic things you can do is to make a spoiler on it. So this is the same type of thing that you would see on a car. So I'm going to try folding it up on both sides, just eyeballing it. It'll be a little uneven. So now, instead of being flat on the top, it's got little spoilers. So you can ask yourself, well, doing spoilers that point up, what's that going to do? So now I'll try throwing this again. And it went a little bit better. Alrighty. So why do you think it flew just a little bit better with these spoilers on it? It's a good question, so keep that question in your mind. Now, what do you think would happen if I folded them down instead of up? All right, and I've got these paper clips. So right now, the way this thing is, try to balance it, or at least just hold it lightly, and then see where is the point where it tips. So it looks like right about there is where it balances. And if I were to fold it in half, fold it right where my balance point is, I can notice it is not balanced right in the middle of the thing. It is more heavily this way. So what happens if I put a paper clip on the back? Do you think that'll make it fly farther or not as far? Let's try. That was maybe a little bit better, but about the same. All right, and when you're trying things like this, I've just tried it once for each of these things, but what an engineer would do is they would try this multiple times. This is a big part of engineering. You're going to try the things that you are designing multiple times through things called a stress test, and that's seeing how well this thing is holding up to this, and I'll show you how well it's held up to my stress test of using it. All right, so my paper airplane here, you can probably tell just by looking at the camera, the nose is bent, and that is happening because when it gets to the end, it tends to dive down. Now that's something really important for designing these that you're gonna wanna keep in mind too. All right, so let's talk, woo, hit my computer there, it's rocking. All right, so now let's talk a little bit about the science behind this. So I talked about the engineering, which is the designing part of this, but let's talk about the pure science of it. So this is aerodynamics. And if you don't know what that means, that is okay. So aerodynamics is the way objects interact with air. That's the simple definition of it. So solid objects like this going through the air, it's the way this is interacting with the air. All right, so something really important to keep in mind and something we don't tend to think about. I talked about this in another science explosion too, but I think it's worth repeating that air is not just something that exists with the wind. It's not something light and fluffy around us. Air is a real thing. So it's a gas, it's not a solid, but it's all around us and it has weight, it has substance to it. So think about an inch, I'm not great at distances, but something around that, an inch squared. So that means or an inch cubed. So that'd be like an inch by an inch, and then an inch deep. How much do you think that weighs if it's air? Do you have a guess? So think about how much you weigh, if you know that. And then think about air all around you. How much do you think just so an inch is measuring one distance. A cubic inch is measuring two, or excuse me, a square inch is measuring two. So 1, 2, and a cubic is measuring in 3 different measurements. So 3 dimensions is what that's called. So like this paper, I could measure the surface of it with 2, going up and down and left and right. But a solid object like these scissors, which don't have a lot of depth to them, I would need to measure in 3 dimensions: up, down, left, right, and then how deep they are, forward and back. All right, so if you don't know the answer to that, it is 15 whole pounds per square inch. So that is a lot. So think about how much you weigh. So if the amount that you were was taken up by air, all right, it would be more than what you weigh. So there are thousands, millions of pounds of air pushing down on you all the time. But here's the trick. It's all around you. So if all the air was just above your head, you would feel it. Think about if you were to put 15 pounds on your head. So if you had a baby sitting on your head, then you would notice that weight. And if you had thousands of them on your head, you would definitely notice. But here's the thing. It's like it's all around you. It is that it's all around you. So every single part of you, so it's underneath of you, to the side of you, air is everywhere. So I keep talking about this because this is a really important point to make. Air is all around you. And if you're wondering, some of you are pretty sharp. Well, all of you are really sharp, but some of you might be thinking already, so if there's air all around me everywhere, but then air stops when I get to space, because I happen to know that there's no air in space. So when I go up, is there less air? Is there less air pressing down on me then? And if you happen to be thinking that, then good job to you, because that's exactly what happens. When you go up higher, there actually is less air in the atmosphere, and there is less weighing down on you. So things actually work differently when you go up. So I used to live up in the mountains, and water actually boils at a different temperature just because of the different amount of air up there and less air pushing down. So it's really cool. But anyway, all right, so let's keep going on this. So this paper airplane, when I throw it, is it flying through the air? What do you think? All right. Am I trying to trick you with this question? Maybe just a little bit, yeah. So the real answer is no, it's not flying. Instead, what it's doing is gliding. So here's the difference. So we tend to just say flying for all sorts of things that are going through the air if they're soaring. But there's a big difference, and it's a pretty simple one. So this paper airplane is gliding through the air because it's not powering itself. Now, if it was flying, or if it was powering itself, then it would be flying. So think about this. When I throw this, it goes through the air, and once it's left my hand, nothing else is pushing it. It's just going by the power of my hand throwing it forward. But if this had a motor on it that was driving it, then it'd be flying. So think about the difference between somebody, if you've ever seen hang gliding, versus somebody in an airplane. A hang glide, they're going to jump off of a cliff and with their glider, and they're going to glide down to the ground. But if you're flying, then you are going to be powering yourself. And you might be thinking to yourself, I don't really see what the point is in this. what this difference is, but there's a big difference in the results that you get because of this. And that is that when you are gliding, for the most part, you are going to keep going down. All right, so if you've seen Toy Story, the first one, then you will know the line "falling with style." So I can tell you flat out that Buzz Lightyear, while he was doing an impressive job of falling with style, what he was doing wasn't flying. He was gliding, though, because he's continually going down until he hits a ball or something and jumps back up. But when he's going down, he is gliding. But when he's got that rocket on his back, now he is flying because he's got his own power source. So think about the difference in birds too. And you can do both. So this is what birds do. So if you look up in the sky, next time you see a bird flying, notice if it's flapping its wings. If it's a small bird, I can almost guarantee you it's going to be almost continually flapping its wings, because small birds need to flap their wings to keep going. But next time you see a large bird in the sky, see how often it actually flaps its wings. So if you notice something like a hawk or an eagle or a turkey vulture, which we've got a lot of around here, then you'll notice that they don't actually flap their wings a lot. So even though they're flying, because they are powering themselves, most of the time, if you were to break it down, what they're doing is gliding. They've got very, very wide wings that are going to help them glide. All right, so that brings me a little bit to what I'm talking about here too. So if you'll notice, my paper plane here, it's fairly tall and not very wide. What if I were to change that? So what if I were to bend this in a different way to give it wider wings? So I'm going to bend it so that this flat part meets this flat part. And then do the same thing on the other side. And now look at how much wider. Now I did that very quickly, so that's a very sloppy job, but you're going to get the point of what I'm saying. So keep in mind, air is a real thing and you're interacting with it. And you can notice that yourself. If you move your arm fast enough, you'll feel really silly doing it like I do now, but you're going to feel the air rushing past it. And that is you interacting with the air. So now that I've widened this quite a bit, if I toss this now, it's going to be able to interact with the air a lot more. So when I say interact, if you don't know that word, that's okay too. So that just means that it's going to, interacting with something means that it's participating with it. It means that it's doing something with that thing. So I'm going to throw this one more time here. And that flew much farther because it's got the wider wings. And even more importantly for me, with the distance, it also ended its flight very different. So I can't show you that because that'd be way too much moving the camera around. But the original one I had, it flew and then it dived. This one flew and then kind of lost energy and then fell. But more of a this kind of falling. And that means that also it was up in the air a lot longer than the other one because it held this down. So, all right. Let's do another quick experiment. You'll need 2 sheets of paper. One of them. All right, step 1 for this paper, you take your paper and you're done. Good job on that one. All right, now the second sheet of paper, what you're gonna do is make it into a cone. So you're gonna take this corner and this corner. And you're going to twist it like this. And then you're going to paper clip it right on top here. And to make this fair, you should also put a paper clip on your other sheet of paper. All right, So then what I want you to do, hold one sheet of paper like this and one sheet of paper like this, hold them out to the side at the same height, and then drop them. And then notice which one falls to the ground first. Well, my cone fell apart, so I'm going to try to get that back together. Because mine ended up tipping over, so let's try this one more time. So if you manage to keep your cone upright, which is a little bit difficult, then what you should notice is them falling at different speeds, and I'll let you do it yourself to see. And now I want you to switch this around. Still drop this one this way, but then do this one upside down and see which one hits the ground. All right, so what you should notice for that one especially is that when this is upside down like that, this is gonna go to the ground way faster than your flat sheet of paper. Now, why do you think that is? What do you think? All righty. So if you said that it was interacting with the air in a different way than the flat sheet of paper, then you're right about that. So you might have gotten more specific. You might have even used the technical terms, and that is great for you as well. So when this flat sheet of paper is falling, it is interacting with lots of the air. The air is all hitting this, and it's meeting what's called air resistance. So that means the air is resisting or fighting this thing from falling. But when it's in a cone, then the air is getting pushed to the side by the point of this thing. So it's going whoop, all around it. So this can fall much faster. So if you've ever noticed how a rocket is shaped with a point, that is really why. It helps it to cut through the air. All right, I'm gonna grab some water real quick. All right. So this is a paper airplane, but what about real airplanes, the ones that you fly in? Now, I think for me, science doesn't make things less interesting or less, I guess magical is kind of the word that some people use for this. It makes them more interesting. So when I look at those giant tubes of metal flying through the sky, I think it's pretty impressive. So those are flying, they're not just flying, they're powering themselves, and the way they do it is pretty cool. So think about an airplane. You've got the body of an airplane, and it does have that somewhat pointed nose, and then it's got two wings at the side, and then it's got the tail in the back. All right, so how does an airplane fly? That's a good question, and there's a couple things with that. So first of all, it's got engines, and the engines provide power, or what's called thrust. And thrust is just the power that's moving it forward. And it moving forward is really important to how it flies. So unlike something like a bird that uses its arms to flap itself and pushes itself up, planes work differently. Also, going back real quick to those gliding birds, like those hawks and eagles, you might have been thinking earlier that even though they're gliding, they look like they're going up, and they are. So that's why I said for the most part, when something glides, it just goes down. What they're doing is they're actually riding air currents. So just like there's currents underwater, there's currents in the air too, and they are riding warmer air, which rises to go higher. It's pretty impressive how they do that. If you get the chance, just watch some of them. There's quite a few gliding birds around here, and I saw an eagle the other day too, and they're really fun ones to watch. All right, so the plane has engines. If you were to picture, I know this doesn't quite look like a real airplane, but bear with me here. So it's got engines here and here. Now those are turbine engines, which just means they're very, very powerful. Well, it means something different, but for the most part, it means they're very powerful engines that suck the air into them. Now, an old plane has a propeller in the front of it, and that spins, and what that's doing too is virtually the same thing. It's also providing thrust. Now, when I say virtually, I wonder if people know what that word means too, because you've probably heard people say it in a couple different ways. So when people say virtually, they mean one of two things usually. They could mean virtual as in the virtual world, like internet, digital type things like that. But when I say something is virtually something, what I mean is that for all considerations for it, it's practically that thing. So you'll hear that word quite a bit, and I feel like I say that one quite a bit too. But whether you've got an old prop plane, which is what those ones with the engines that spin in the front, or whether you've got one of these new ones like a 747 or beyond that's got those huge, powerful turbine engines, all those are doing is providing thrust. They're bringing air in, shooting it back, and making it go forward. It'd be the same thing if you have a rocket on the back of it as well, which works a little bit differently. Rockets work by burning something, and then the fumes and the exhaust from that pushes it forward. That's not how your car works, by the way. Your car is not a rocket engine. It burns fuels, but it does it in something called an internal combustion engine, which is powering movement in there, but it's not powered by the exhaust. The exhaust of your car is what's called a byproduct. It's the thing that happens because of it. It's not the thing you're wanting to happen. Alrighty. So anyway, that's a whole nother story, but an airplane. So it's got the thrust from the engines, but then I think the coolest thing about airplanes is how they actually work with the wings. So airplane wings work by using the power of air being a real physical thing to do some cool stuff with them. So imagine air, this going through the air, pretend this is an airplane, it's being thrust forward, and it's got the two wings on the side. Now you might notice if you look at an airplane wing that they're curved. So they're shaped about somewhat flat on the bottom and then kind of curved on top like this, and that's very much on purpose. So let me shape this a little bit so it looks like that. That's the nice thing about paper. You can do a lot with paper. So an airplane wing is going to look something like this. And that shape's really, really important. So what happens when an airplane is being thrust forward, then the air is moving above and below that wing. So keep in mind, so this is a big thing in physics. We're going to jump into physics for just a little bit here. The two objects cannot occupy the same space at the same time. So those air molecules are not going to be in the same place as the wings. So they have to either go over or they'll go under. Now, a really cool thing happens when they go over and under. When they go under, they're mostly just passing through. But when they go over, they have to go over that curved shape. And that actually makes the air travel faster over the top of the wing than on the bottom. So there is actually a higher air pressure because of that underneath of the wing than above it. And what happens when you have a higher air pressure in one part and a lower air pressure in the different part? Well, it's going to want to balance out. And that means that that higher air pressure is going to push on the bottom of the wing. So while the plane is pulling itself forward, airplanes don't use their engines to make themselves go up. The only thing their engines do is pull them forward. Their wings are what pull them up. Pull's not really the right word, but I'm going to use it just to make this a little simpler. So as it's pulling itself forward, the pressure of the air is forcing the airplane to go up. Alrighty, and there are some great pictures of this online too. If you just search online for how do wings work, or how do airplane wings work, because you're going to get a very different answer if you're looking up for birds, or how do airplanes work. There are some really cool charts on this, but that's the basics of how that works, is that the air is different pressure underneath the plane, underneath the wing than above it. It's moving faster above the plane and slower below, and there's a higher pressure below, and that pushes it up. All right, And then you've got these kind of spoiler type things on the airplane that you're riding in as well. And those are for a couple things. They help to provide balance for this, or they would if I had folded this better. And that is okay, you know. But they also help to provide drag if they are moved around in a certain way. So drag is when something is meeting pressure against that. So if you're ever on an airplane and you get a chance to look at the wings, notice that on the back of the wings, there's always these flaps that go up and down at different types. And that is to change the drag on the wing of that plane. It helps them to turn and it helps them to slow down at the right moment. Now they'll lift pretty much all of the flaps they have when you're landing. Next time you get the chance to look at how a plane lands, you'll notice that they do that. And if you're going really, really fast, sometimes you need a lot more drag. Or remember, drag is just the resistance of the air. It's the something fighting against you moving forward. Then think about the space shuttles returning. Now you might notice they don't just have flaps, they have a full parachute when they land. And it works the same way as if you have a parachute backpack on. So a parachute works by having a big surface area. So a surface area is just the area of the surface. So what that means is it's the whole space that the surface of something takes up. So this paper, because I haven't folded it at all, has a huge surface area, actually a larger surface area than this. And so if I were to drop these to my side, then the plane drops much faster. And a big part of that is because it's got less resistance from the air because it doesn't have as big of a surface area. So a parachute is big for the whole reason that it provides a lot of drag from its large surface area. So the space shuttles have that because they're going incredibly fast. They need a lot to slow them down. And if you happen to jump out of a plane and you've got a parachute with you, then you will use your parachute to slow you down as well. It's got a huge surface area for that reason. All right, so we've made a paper airplane. Now it's time to make another paper craft here. So you're going to start out with a square sheet of paper. Now, if you don't know how to make a square sheet of paper, I'm going to let you in on the secret. It's very easy. So you take a normal sheet of paper, which are always rectangular like this, and you're going to fold this corner so that it meets the flat side here, just like this. All right, so you just fold it over like that. So this flat side meets this flat side. Then you'll take your little rectangle that's sticking out here, fold it over top of this. So it's folded like that. And then that gives you a nice crease that you can easily cut. So that's a mostly straight cut. Great. All righty. So you're going to take your square, which if you did it just like I did, then you'll already be done with the first step, which is to fold the square in half, corner to corner, so that you make a triangle. All right. Then you're going to fold the corners again to make yet another triangle. What kind of triangle is this, by the way? Do you know? Yep, it's a right triangle because this is a right angle. That means it's 90 degrees. Alrighty, so it should look like this then. You've got a smaller right triangle than you started out with. All right, Then you unfold the previous fold that you just did so that you've got your larger triangle again. And then, this is a little more complicated of a fold. You're gonna get this flat side to meet with the crease here so that it's like a kite. See that? So you're doing this. And then you'll do it on the other side. Have you guessed yet what we're making? It's not a paper airplane. All right. I'm gonna remember, I think. Okay, then here's another slightly more complicated fold. This flat side right here. So remember, it's this part you folded up like this. Take this flat part, and you're gonna make it meet with this flat part right here, this edge flat part. Like this. All right, so I'll show you from this angle. So remember, this is the little kite shape we made. So this part is going to meet up with here. All right. And then fold this crease again to get it down. And then you're going to spread these edges out just a little bit. And that's it. So you might be thinking, well, okay, Zach, we're done, but I don't know what it is. So what this is a paper hovercraft. And this is going to work differently than a paper airplane. This isn't going to fly through the air. This is going to hover above the air or above a surface. So remember, flying is self-powered flight. Gliding is going through the air if you're not powered. And this is going to be hovering. All right, so I'm going to test it out here. Let's see if you can see. Can you see it? Yeah, there we go. All right, so I've got a balloon plump. You could just blow on it too, but I'm going to use this to get it going. So, all right, turned around a little bit. If you can make this as even as you can, then that'll really help. I'm going to flatten it a little bit too. I think it's a little too tall there. All right. So, man, this was really hard to not get to turn. You might have to play with this a little bit. But anyway, it'll go across the surface. So even though part of it is still touching the surface, the air underneath of it, which remember is a real tangible thing, so that means you can touch it, it is pushing that up. It's creating air pressure that's more underneath of it, so it's helping it to hover above that. By the way, I have made a leaf blower hovercraft before too, which is the kind that you can actually ride on, and it's a lot easier than you'd think it would be, and it is a very fun project. That's a little more complicated than something I'd want to do on this, but it might be something I'd do as a home project again to just kind of show people what that is. Lots of fun though. Alrighty. Yep, so this is creating something called lift, and lift is what helps things to rise, whether it's the hovercraft or the airplane. All right, we're gonna make one more thing here. And that is gonna be a helicopter. All right, so take a sheet of paper. And you can find plans for these online, but I think they're honestly fairly easy to just make yourself. And I think about 1/3 of a sheet works well. So if you don't know how to make 1/3 of a sheet, you fold over, so like this one side and the other side, so they're about even. This doesn't need to be perfect for that size, just so that you get about the right size of this. And then use your scissors to cut along the crease. Somewhat evenly. So you've got that. Alrighty, so now you're going to want to visualize a T shape on here. If you've got a pencil, you can draw that out. Otherwise, just think of a bold capital T. All right, and you're going to need to make a couple cuts and a couple folds on this. So the first one, you're going to cut down, I'd say about 1/3 of the way. So it's like that. And hold on here, let me grab my model here because I made this earlier. All right, and then you're going to make 2 more cuts, but a little lower. So if you were to cut here, that would be bad because you don't want to cut one of these off. So I'd say about 1 inch lower than that. You're going to make a cut about halfway to where that middle line is. This is not precision engineering, if you couldn't tell. Alrighty, hey everybody. Here is a little bit of an addendum to that last one. That paper helicopter didn't look right to me, and I realized that's because it wasn't quite right. So what I had done is I had folded this part and then made it so that the flaps were just like that, and that didn't look quite right to me, so I realized what I did wrong. All right, so what you need to actually do, take your sheet of paper back out, and so you've got your cut here, your cuts here, and then you're gonna fold them all like this one here, this one here, then you're gonna fold your sheet like this, and then the other one the other way. Alrighty. So here we go. Now it looks a little bit more like a helicopter. So let's try getting that. There we go. And you can also do your paper clips on the bottom to give it some weight. That'll make sure the bottom part will stay down. Like so. Drop that. And you'll see it spin much better than the last version of it. So sorry about that, everyone. But you'll notice when this falls, it's going to fall like that. So now, why I was saying try folding in a different way. So try folding them flipped around. And then see what happens. Notice which direction it spins. Fold it back the other way. So depending on which way you've got the blades, it'll either be clockwise or counterclockwise. Alrighty, so thank you for bearing with me on that. I knew that that one didn't look quite right. I just needed to check that one. So this is what it should look like, and it'll spin just like that when you do it. Thank you very much, everyone. Bye. So a helicopter is going to work by self-powering it. It's going to spin, and those blades are going to create lift by pushing itself down. So remember, an airplane, the blades or the engines, they're going to spin and pull it forward, and then it's going to get lift by its wings. But a helicopter is actually going to be pushing itself up with the wind resistance going down underneath. Now these are obviously not pushing themselves up, they're spinning while they go down. And they're going to fall a lot slower because they've got wind resistance from all of these parts. So you can try seeing how much putting different weight will affect on them, balancing them in different ways, or try to make this part longer or shorter, and then this part longer or shorter as well. There's a lot that you can do with these, a lot of different experimentation. Alrighty, so those are the 3 different paper crafts that I have for you today, but I want to recommend a couple books we've got at the library if you're interested in making more of these types of things. So we've got How to Make Paper Airplanes. So simple enough. This is by Captain Ralph S. Barnaby, retired of the U.S. Navy, and Captain Barnaby talks all about all of the basics of making a paper airplane, lots of different designs, how to make some really fun, interesting ones like these super gliders that he's got in here. There are all sorts of really cool ones that are in here. I would encourage you to take a look. And then if you're interested in making other types of things out of paper, which I think is always a fun thing to do, we've got Making a Paper Airplane and Other Paper Toys by Dana Macon Rao. And this one's got a lot of fun different types of things in it here, like making a paper airplane, origami, which, by the way, most origami you're going to start out with a square sheet of paper. So knowing how to make a simple one like I showed you out of just a basic thing here, that's always good to know. Also, this is a classic one from when I was a kid too, is making things out of gum wrappers like this gum wrapper gecko. So both of these are great books. I would really recommend that you check them out. So thank you everyone for joining me for Science Explosion. We have learned all about aerodynamics, a little bit of engineering. We've learned the difference of flying versus gliding versus hovering, which, by the way, are all different than floating. Floating, which I've had in the title as well, is going to be something that is on top of a liquid. And you can just as easily make a paper boat. A lot of the principles are going to be the same as making a paper airplane, but it's going to be about buoyancy, which is how well something floats too. And so there's some great tutorials on that in this one as well. And we've got lots of different books on boats in the library as well if you want to learn more about that. So thank you very much, everyone, for joining me. My name is Zach. We are at Hudson Public Library coming at you online. And next week, we are going to be talking about walking water. If you don't know what that is, then I'd encourage you to join in. And if you do know what that is, then great. Then you can still join in anyway. So thank you very much, and bye.